We know that the moon orbits the Earth, right? And that in this fashion, the Earth orbits the sun. Well, with all of these orbits, one might ask, is there ever a point where any of the three cross paths? The answer to this is yes, and in a couple of different types too. A lunar eclipse, when the Earth passes between the moon and the sun, and a solar eclipse, when the moon passes between the Earth and the sun. This is Cup of Science Joe, and today I'm here to talk about the second of these phenomena. In a couple of days from now, on Monday, April 8th, we will get the chance of experiencing a solar eclipse. I will be experiencing it in a way I have not been able to before, and I'm quite excited for it. I plan on trying to photograph this event too, which I will share here if I am successful. Please note one thing: if you intend on viewing the solar eclipse like I am, you need properly rated eclipse glasses. So right here, I have a pair of such properly rated eclipse glasses. And the thing you want to look for is that they have the right ISO rating, which is ISO 12312-2. I'm going to bring this up here. There we go. It focused. And so you can see the rating right there on the glasses. I thought it would also be cool to make a video for you all on what solar eclipses are, what different kinds of them are out there, and a bit on how and why they occur. There are two primary ways or types of solar eclipses one can experience, and they are distinguished by where on Earth you are in relation to the sun and the moon. A partial solar eclipse, which occurs when the moon is in position to block only some of the sun's light, and a total solar eclipse, which occurs when the moon is in position to block all of the sun's light. The catch to a total solar eclipse is that to experience them, one must be in the path of totality. And this is what I will be traveling to try to get an experience of here soon. Here is the path for the upcoming 2024 solar eclipse. Well, what is the path of totality, you might ask? In short, it is the shadow trail that the moon creates on the Earth as it is blocking out the sun. This path does not always appear in the same place on the planet, and sometimes does not even occur on land. When the moon casts its shadow, it has a darker inner shadow known as the umbra, and a fainter outer shadow known as the penumbra. It is within this umbra shadow that the sun is totally blocked. Because the moon's shadow must extend to reach Earth, the umbra narrows and gets smaller by the time it reaches Earth, so it's a pretty small area where you're in totality. Observers in the penumbra will still get an eclipse, but this is where it's only a partial one. This area is also much larger than the umbra is. Solar eclipses also only occur during the new moon. This is when the moon is out in the daytime sky, it is not visible at night, and it is also aligned on the same side of the Earth as the sun. So then why do we not have eclipses every month with the new moon? This is because the moon does not orbit on the same plane as the Earth and the sun, which is known as the ecliptic. Instead, the moon's orbit around the Earth is tilted by about 5 degrees. So, during the new moon each month, the moon usually passes above or below the sun, and its shadow misses the Earth entirely. We only get 2 times a year when the new moon crosses the Earth-Sun ecliptic plane and provides opportunities for solar eclipses. These are known as eclipse seasons. One might also consider that the sun is huge when compared to the moon. So then how is it that the moon has the ability to block out the sun? And the result of this is truly just a cosmic coincidence. The sun is about 400 times bigger than the moon, and it also happens to be about 400 times further away. This causes the sun and the moon to appear almost exactly the same size in our sky. Not all eclipse events result in a total solar eclipse either. Because the moon's orbit is oval, it has a point when it's closest to us and a point when it is the furthest away. The point when it's closest to us is called the perigee, and if you've ever heard the term supermoon before, this is used to describe the moon at this point in its orbit as it appears larger than usual. But for eclipses, we want to touch on the apogee. This is when it is at its furthest point away from us in orbit. And if an eclipse happens when the moon is at or around its apogee, the umbral shadow does not reach Earth, and the moon does not appear to completely cover the sun. Instead, a ring of sunlight appears around the moon, creating what is known as an annular solar eclipse. In this instance, the part of the moon's shadow that extends from the end of the umbra is called the antumbra, and observers in this zone will see the annular eclipse, while those in the penumbra, like the total eclipse, will see only a partial version, a partial eclipse. And sometimes we even get a combination of these two types, where the moon's umbra will reach Earth's surface in some places, creating a total eclipse, but Earth's surface will curve away from the shadow so that the umbra no longer reaches it in other places, creating an annular eclipse. When this happens, and an eclipse appears total in some places and annular in others, it's called a hybrid eclipse. And again, no matter what type of eclipse you are able to witness, I would recommend taking the time out of your day to step outside and take a look. But remember, like I mentioned earlier in the video, please make sure to use properly rated eclipse glasses if you do so. I hope you enjoyed this and maybe even learned something, and I implore you to step outside tonight and look towards the stars.